Imagine you sit down at your terminal, you open a blank command prompt, and you give your machine this seemingly impossible directive.
Right, like a total moonshot request.
Exactly. You just tell it, hey, build an entirely new operating system from scratch. And the only real constraint is that it has to be capable of running the classic 1993 video game Doom.
Which, I mean, is just the ultimate flex in computer science. Can it run Doom?
It really is. So you don't give it any architecture diagrams, right? You don't provide a code base. You just issue this command, get up, walk to your kitchen to brew some coffee, and when you come back, the system is fully compiled.
The boot sequence is done.
Yeah, and the iconic Doom Marine is just standing there on your screen, fully playable. And the crazy part is, not a single human being typed a line of code.
It's wild to think about. But, the mechanics of how it actually happened in that test case are so much more profound than just the game itself.
Because it didn't just search GitHub and copy-paste an old OS, did it?
No, not at all. It utilized this totally new architecture of autonomous delegation. The primary AI received your natural language prompt, and it realized the scope was way too big for just a single linear output.
So it basically panicked.
Well, not panic, but it autonomously spun up an entire virtual software company in the background. It created, like, a lead architect agent to define the kernel structure.
Oh, wow. So it's delegating.
Exactly. And then a C++ developer agent to write the memory management protocols, plus a QA agent that sat inside a secure sandbox, just compiling the code, finding syntax errors, and sending those errors right back to the developer agent to fix in real time.
That is just, that autonomous loop, that virtual software company running at light speed inside the machine, that's exactly what we're going to pull apart today.
It really is the core of everything right now.
Right, because the machine building Doom while you get coffee is a phenomenal party trick. But when you think about what happens when that exact same autonomous intelligence gets the keys to your inbox or your calendar or your bank account, that is a massive paradigm shift.
It changes the entire way we interact with technology.
It does. And that's our mission for this deep dive. We are sifting through this massive data drop from the May 2026 Google I/O event to really decode what the tech industry is officially calling the Agentic Era.
Which is such a crucial term to understand.
Yeah, because we're officially moving past the days of just typing a question into a box and waiting for a text summary. We're entering this era where you just declare an intention and an army of invisible agents orchestrates a whole thing across the internet.
Right, because if you look at the defining characteristic of the previous era, what we should probably just call the reactive AI era, it was highly binary. It was transactional.
Like a really advanced encyclopedia.
Exactly. You type a prompt, you hit enter, and the model calculates the most probable sequence of words to satisfy that one specific prompt. And then it just stops. It returns to a state of absolute zero.
It has no persistent memory of your actual goals.
None. It doesn't initiate actions, and it definitely doesn't collaborate with other systems unless a human explicitly clicks a button to tell it to.
I always think of it as the digital equivalent of a fast food drive-thru. You place your order, you get your bag of food, and the transaction is complete.
That's a perfect analogy. But the architecture they detailed in these I/O developer blogs describes something entirely different. I mean, they released this metric on their current processing load, and it's staggering.
Wait, the token count, right.
Yeah. Google's models are now processing an unfathomable 3.2 quadrillion tokens per month.
That is just, 3.2 quadrillion. To put that into perspective for everyone listening, that is a 7-fold increase from just 12 months ago.
A 700% jump.
Right. And you don't get a 700% jump in compute simply because more people downloaded a mobile app or, started asking for more pasta recipes.
No, you definitely don't. That massive volume is the mathematical footprint of continuous background computation.
Okay. So it's always running.
Exactly. In the agentic era, the AI isn't just sitting around waiting for a prompt. It's maintaining state. It's continuously evaluating data streams against your previously stated goals.
So it's churning through your incoming emails, checking global pricing databases, pinging your calendar APIs.
All of it. It's constantly asking itself, hey, does this new piece of information require me to initiate an action on behalf of my user? And obviously doing that requires an unfathomable amount of compute power.
Which brings us to the physical foundation required to actually run 3.2 quadrillion tokens a month without, melting the planet or bankrupting the company.
Right, the hardware matrix.
Yeah. Google introduced this totally bifurcated hardware approach with their new custom silicon. They have the TPU-8 and the TPU-8i, and these are powering the new Gemini 3.5 Flash model.
And if you look at the specs, these aren't just incremental little upgrades. They serve two completely different masters.
Let's break that down, because historically, silicon design for machine learning was always a game of compromises, wasn't it?
It really was. You tried to build a single chip that was, pretty good at the massive brute force math required to train a model, but also decent at serving that model to the actual end user.
But they've completely abandoned that unified approach now.
Completely. So the T in TPU-AT actually stands for training. These arrays are designed specifically to operate within JAX and pathways, which are their distributed computing frameworks.
Because training these frontier models has basically hit the physical limits of a single data center, right? Like, you can only pack so many servers into one building before you literally run out of localized power or cooling capacity.
Precisely.
Yeah.
It's just the laws of thermodynamics. So pathways allows them to shard the training data, basically splitting the neural network across multiple geographically dispersed data centers.
Oh, wow. And they synchronize it.
Yeah, they synchronize the learning across these massive optical interconnects. So the TPU-8 is highly optimized for that specific high bandwidth global synchronization. It is purely the engine of learning.
Okay, so if the AT is the university where the model learns, then the TPU-8i is what actually touches the user.
Exactly. The I stands for inference. Think of it as the nervous system that executes the actions in the real world.
And reading through the sources, the singular obsession of this 8i architecture is low latency delivery.
Because latency matters so much more now.
Yeah.
In the reactive era, if you asked a chatbot to write a poem and it took like 3 seconds to start generating text, you barely even noticed.
Right, you just waited.
But in the agentic era, if your AI agent is out there negotiating a complex task, say it's navigating a third-party website, clicking buttons, reading the screen state, every single microstep requires an inference call.
Oh, I see. So if there's a 500 millisecond delay on each of those calls, a 10-step task suddenly takes 5 seconds.
And the user experience just degrades instantly. Feels clunky.
It creates that uncanny valley of lag where you start wondering if the whole system just crashed.
Exactly. So the 8i, paired with this highly optimized Gemini 3.5 Flash model, is operating at speeds 4 to 12 times faster than the previous generation.
Which effectively collapses the time between your intention and the actual execution to near zero.
It does. And the financial extrapolation of that speed for businesses is wild.
Yeah. The enterprise impact reports were crazy. Large-scale enterprise clients that are migrating their internal agents to Gemini 3.5 Flash are projecting operational savings north of $1 billion a year.
$1 billion. Because in cloud computing, time is literally money. You are billed for the exact milliseconds your compute cycles occupy the server.
Right. So if your internal HR agent can process a complex onboarding workflow like verifying tax documents, provisioning software licenses, setting up payroll, and it does it 12 times faster.
Your server costs plummet linearly. It frees up massive amounts of capital.
Money that can be redirected from just basic operational overhead into pure aggressive product innovation.
That's a massive competitive advantage.
Okay, let's unpack this for a second. We've established the hardware matrix. We have these specialized training arrays, lightning-fast inference chips, and an architecture built for continuous background processing.
Yep.
How does this actually manifest for you, the listener, on a random Tuesday morning? Because this is where Google introduced Gemini Spark.
Yes. Gemini Spark. They are explicitly positioning this as your 24/7 digital chief of staff.
I love that they chose the term chief of staff over assistant. Because an assistant waits for a highly specific linear command, right? Like schedule a meeting at 2 p.m.
Exactly.
Ah.
But a chief of staff understands your overarching operational context. It executes multi-layered directives autonomously.
And crucially, reading the white papers, Gemini Spark does not live natively on your local device hardware.
No, it operates on dedicated virtual machines within the Google Cloud.
Which means it's totally untethered from your physical hardware state.
Yeah.
Like if I issue a command, close my laptop, shove it in my backpack, and then completely lose cellular service on the subway, Spark is still running.
It is. It's maintaining the state of your request on the server side. It fundamentally breaks the requirement for active user supervision.
So as requested by our listeners, let's look at some really practical examples of what this looks like for daily chores. The Keynote provided 3 incredibly specific routines automated by Gemini Spark.
The demo is fantastic because it showed how Spark handles really colloquial, unstructured human input.
Right. The user just speaks this chaotic stream of consciousness directive into their phone. Let's walk through the exact mechanics of these three routines because it perfectly illustrates the leap from basic text generation to true agentic orchestration.
Let's do it.
So the first practical example. The user says, find all upcoming meetings with Sundar and color code them hot pink so I don't miss them.
If we break down the computational logic required for that single sentence, it is staggering. First, the AI has to perform semantic parsing just to identify the intent.
Right, because Sundar could be a contact, a client, or just a random keyword in a Google Doc.
Exactly. It has to recognize that the context implies Google Calendar. Then it executes an API call to your calendar, running a search query across all your future states.
But it doesn't just stop at retrieving the data, because the command color code them hot pink isn't exactly a native Boolean logic string.
No, the agent actually has to map the human colloquialism, hot pink, to the closest available hex code within the calendar API's supported color palette.
It's amazing.
And then it has to construct a series of PUT requests to physically alter the metadata of those specific calendar blocks, execute the changes, and verify the new state.
All entirely in the background. Okay, so that's the first example. But without missing a beat, the user in the demo just adds a second task in the exact same breath.
The neighborhood block party.
Yes. The second routine. Draft an invite to the new neighbor for our block party because they weren't on the original guest list.
This requires a massive contextual pivot from the AI. The agent has to drop the calendar API entirely and spin up a new set of subagents.
It's shifting gears completely.
Completely. So one subagent searches your localized data, probably your recent emails or your contact database, just to figure out who the new neighbor actually is.
And then another subagent has to hunt down the disparate details of the block party itself.
Right, it dives into a past calendar invite or a WhatsApp thread to grab the date, the time, the location.
And then, this is the crazy part, a third subagent synthesizes all that retrieved data into an outgoing communication, and it actively adopts a warm, welcoming tone that's actually suitable for a new neighbor.
And it holds that drafted communication in a pending state for your final approval.
Okay, so then we get the third practical example in the sequence, which is honestly the holy grail for any parent managing household logistics.
The school checklist.
Yes, the user says, create a comprehensive end-of-school-year checklist for the kids, automatically categorizing tasks by deadline and priority in a formatted Google Doc.
This one really highlights the agent's ability to impose structure on abstract concepts. It isn't just pulling a pre-made template from some server.
It has to figure out what that actually means.
Exactly. It utilizes its knowledge graph to understand what an end of school year implies. You know, returning library books, cleaning out lockers, buying teacher gifts, finalizing summer camp medical forms.
The stuff you haven't even explicitly told it to do.
Right. It generates these logical tasks, assigns them inferred priority levels, and then interfaces directly with the Google Docs API to physically render a formatted table.
Bold text, bullet points, date columns, the works.
All of it.
You literally speak a chaotic, three-part brain dump, put your phone in your pocket, and Spark parses the intent, divides the labor, and fundamentally alters the state of your digital life. It's saving you hours of manual clicking and scrolling.
And this proactive capability scales up into a feature they're calling the daily brief. But again, we really have to look past the surface level here.
Because we've had Morning Digest emails for a decade, right?
Exactly.
Yeah.
But the difference here is that the daily brief doesn't just summarize your data. It surfaces actionable intents.
Let's give the listener an example of an actionable intent versus a basic summary.
Sure. So a summary says, hey, you have a flight to Chicago tomorrow at 8 a.m., and you have an email from the library saying your book is overdue.
Which is helpful, but it leaves the burden of action entirely on me. I still have to open the airline app to check in, and I have to log into the library portal to pay the fine.
Exactly. The Agentic daily brief reads that exact same data, but it uses its WebMCP capabilities, which we'll dissect later, to preload the execution.
Oh, nice.
Yeah, it presents a button right in line that says, check into flight and secure aisle seat. And another button that says, renew library book for 2 weeks.
So the agent has already done all the heavy lifting of navigating those underlying websites and systems. It's literally just waiting for your cryptographic signature to finalize the action.
It turns the user from a micromanager into an executive decision maker. You are merely approving the strategic moves that your staff has already prepared.
I really do love that executive analogy, but here's where I want to push back a little on behalf of the listener.
Go for it.
If I am the CEO of my digital life, I absolutely need to know what my staff is doing. If I have these invisible agents constantly reading my emails, messaging my neighbors, moving things on my calendar, how do I stay in control?
It's a huge concern.
Right, like if my phone throws a push notification every single time an agent executes a subtask, the cognitive overload will be worse than if I just did the tasks myself.
The problem you were describing is essentially the defining UI/UX challenge of the entire agentic era. How do you balance autonomous execution with user transparency?
Because if it's a black box, I'm going to assume it's broken or doing something malicious. But if it tells me everything, it's just annoying.
Right. So Google's solution, which they outlined in the Android 17 documentation, is a feature called Android Halo.
Android Halo. The docs describe it as an ambient indicator, right? Not a standard notification badge.
Exactly. It is a soft, pulsing, glowing ring that manifests to the very top edge of your phone's display. It's specifically designed to be perceived by your peripheral vision without demanding foveal attention.
So when my digital chief of staff is out in the cloud working, maybe it's monitoring a flight price or formatting that school checklist, the halo just kind of breathes.
It breathes. So it's acknowledging that work is happening, but it's not hijacking your focus to tell you the boring specifics.
But what if I want the specifics? What if I have a moment of doubt and I suddenly wonder, wait, did I tell it to email my boss or my new neighbor?
That's the brilliance of the interaction model.
Yeah.
If you want transparency, you simply tap the halo.
And it drops down the actual execution tree. I saw that in the documentation. It reveals this highly granular real-time log.
Yeah, it will explicitly state, currently scanning inbox for flight itineraries or executing row 14 formatting on Google Doc.
It gives you absolute transparency on demand. It solves the anxiety of the black box by giving you an instant window into the agent's logic state.
And crucially, it allows you to pause or kill the operation immediately if you see it hallucinating or just going down the wrong path.
It's a really elegant solution to the very real anxiety of letting a machine run your life.
It is.
Okay, so if we transition away from how we manage our personal logistics and we look at how we interface with the broader internet, we have to talk about the death of the most iconic piece of digital real estate in history.
The traditional search bar.
The empty white box with the little magnifying glass. It has literally defined human-computer interaction for over 2 decades.
It has. But its underlying architecture, text in, blue links out, is fundamentally incompatible with an agentic ecosystem. So the search bar has been replaced by what they call the intelligent search box, which is intrinsically multimodal.
Let's unpack intrinsically multimodal, because I think people hear that phrase and they assume it just means Google slapped a microphone icon and a camera icon next to the text box.
Right, like they've done for years. But the I/O deep dives emphasize this is an architectural overhaul at the embedding level.
What does that mean in practice?
Well, when you had separate text, image, and audio search functionalities in the past, they were essentially different databases bolted together. Like if you search by image, the system tried to guess the text metadata of that image and then run a standard text search.
But an intrinsically multimodal architecture maps all forms of human input into the same high-dimensional vector space simultaneously.
Yes, powered by Gemini. So an audio file of a sound and a PDF of a dense technical manual are converted into the exact same mathematical language.
They share the same geometric space in the model's brain.
Exactly. And this allows for the example they demonstrated in the Keynote, which I think completely breaks the old paradigm of information retrieval.
Oh, the car engine example. This is brilliant because it's such a real, visceral human problem. Your car is making a terrifying noise.
Right. And in the old reactive era, you were forced to try and translate an audio experience into text.
You're typing, car makes weird clunking rattling sound when turning left, and you just get back a forum post from 2014 about a completely different car.
Because language is a highly inefficient compression algorithm for sensory experience.
But with the intelligent search box, you don't translate. You just capture the raw data. You upload a 10-second video of the engine making that specific rattling sound.
And at the exact same time, you upload a 300-page PDF of your specific vehicle's highly technical service manual.
Right. And then you just speak a natural language query over it all. What is that rattling? And based on this manual, how many hours of labor will a mechanic charge me to fix it?
The agentic orchestration required here is a symphony of vector matching. The audio embeddings of your engine's acoustic signature are cross-referenced directly against the structural schematics and diagnostic flowcharts hidden within that PDF manual.
While the natural language agent parses your spoken constraint regarding the hours of labor.
Exactly. The system doesn't just give you a link to a website. It synthesizes a bespoke answer based on the exact physics of your specific problem.
It effectively acts as a master mechanic, reading the manual while actively listening to your engine. It's incredible.
But the search evolution doesn't stop at answering immediate questions either. The sources introduce these information agents, which transition search from a reactive query into a persistent, autonomous state.
Yes, I wanted to highlight this because of how much time this saves. We've all experienced the brute force method of tracking information online, right?
Oh, absolutely. You want to buy tickets to a sold-out concert, or you're trying to find an apartment in a highly competitive market? What do?
You open 5 tabs and you hit the refresh key every 30 minutes for 3 days straight.
Right. You act as a highly inefficient biological cron job.
I have absolutely lost hours of my life refreshing inventory pages for specific hardware components.
Well, information agents offload that biological burden to the cloud. Instead of running a search once, you program an agent to inhabit the search parameters permanently.
The apartment hunting example from the documentation really highlights the semantic depth of this, because you don't just set a basic price alert.
No, it's way deeper than that.
You tell your information agent, I am looking for a 2-bedroom apartment in this specific neighborhood, but it must have south-facing windows for natural light, and it needs to be under this exact price.
And this is where the multimodal understanding is so critical. The agent isn't just scanning text listings for the hyphenated phrase, self-facing.
It's looking at the pictures.
It is actively analyzing the image carousels of new apartment listings. It determines the orientation of the windows based on the provided floor plans or even the angle of the sunlight in the photos, and cross-references that with the geographical metadata.
It's doing spatial reasoning on the photos, and it runs 24/7. It scans the listing sites, local property management blogs, and social media graphs simultaneously.
And the other example they gave was monitoring the web for a highly anticipated limited edition sneaker drop.
Right, so the agent can monitor retail sites, fashion forums, and the Google Shopping Graph continuously.
And crucially, it operates silently. It does not spam your notification feed with near matches or maybe results.
It preserves your attention.
Exactly. It preserves your attention until the semantic threshold is perfectly met, at which point it alerts you often with the option to execute the purchase immediately via WebMCP.
So search officially becomes a persistent scout rather than just a static directory.
It does.
But what happens when the answer to your question doesn't actually exist on the internet yet? What if the perfect visualization of a complex concept has literally never been built?
This brings us to the concept of generative UI, and specifically the anti-gravity engine.
Right. Because if the agentic era is about removing friction, generative UI is about removing the friction of comprehension.
Historically, the interface you interact with, a web page, a widget, a chart, was hard-coded by a human developer long before you ever asked your question. It is entirely static.
But generative UI flips this. The interface itself is compiled in real time to serve the exact dimensions of your inquiry. So if I ask a wildly specific, complex question, I'm not getting a slightly better Wikipedia page. I'm getting bespoke software.
Yeah. Exactly. The Keynote detailed a fascinating interaction regarding astrophysics. A user asks the intelligent search box to explain the mechanics of how 2 binary black holes orbiting each other generate gravitational waves.
And a text summary is just completely insufficient for that. A 2D diagram is inadequate.
So what does the anti-gravity engine do? It recognizes the pedagogical gap. The agent essentially assumes the role of a front-end developer.
On the fly.
On the fly. It writes the React code, the WebGL rendering logic, and the physics simulation parameters, compiles them within a secure sandbox, and serves a fully interactive 3D manipulation widget directly within your search results.
It builds a custom application for you in milliseconds.
Yeah.
You can grab the black holes on your screen, drag them closer together, alter their mass, and visually watch how the ripple effect of the gravitational waves changes in real time.
The data ceases to be a static file you read. It becomes a dynamic environment you manipulate.
The implications for education and technical training are staggering. I mean, the barrier to understanding abstract, highly complex concepts drops to near zero when the interface adapts dynamically to the learner's specific cognitive block.
It's a complete paradigm shift in knowledge transfer.
But this concept of dynamic adaptation and removing friction extends far beyond just learning. It radically alters the physical commerce of our lives.
It really does. If we look at how agentic architecture is changing shopping, we have to examine the new universal cart.
The universal cart, it's essentially the logical conclusion of the information agent, right?
Right. It is an agentic hub that sits above the retail layer. It's not just a centralized list of bookmarks to different stores.
Yeah, it's not a Pinterest board. It actively monitors the state of your intended purchases. It tracks price histories and supply chain stock levels across the entire web.
But the example that truly blew my mind, because it proves the AI understands physical reality, not just text, was the custom PC build scenario.
Yes, the contextual engineering constraint.
Exactly.
Imagine you are trying to build a high-end gaming computer. You are piecing it together from different retailers to get the best prices. You add a highly specific Intel processor from Newegg to your universal cart.
Okay.
And then 10 minutes later, you're browsing Amazon and you add a highly rated ASUS motherboard to the exact same cart. In the reactive era, the cart just totals the price and lets you buy it.
But the universal cart agent actively interrupts your workflow. It flags a critical error before you ever reach the checkout screen.
Because it warns you that the specific Intel processor you chose utilizes an LGA 1700 physical socket, but the ASUS motherboard you just added only supports an AM5 socket.
The physical pins will not align.
You literally cannot plug the CPU into the board.
And the significance of this cannot be overstated. The agent is not performing simple keyword matching. The word incompatible is not written in the product titles.
Right. The agent is referencing a deep knowledge graph of physical engineering constraints. It understands the spatial geometry and hardware requirements of physical objects in the real world.
And it applies that logical friction to protect the user from a costly physical mistake. It is acting as a master technician looking over your shoulder.
And this understanding of the physical world, what the developer blogs call intuitive physics, is a core feature of the new Gemini Omni model, especially when we look at how it handles content creation.
Gemini Omni was trained specifically to understand temporal and spatial consistency, because standard generative video models often hallucinate wildly.
Like when an object passes behind a tree and emerges on the other side as a completely different shape.
Exactly, because the older models don't understand object permanence. They only understand pixel probability.
But Omni understands the rules of the matrix: gravity, momentum, light occlusion.
The Keynote demonstrated this beautifully with a prompt asking for an educational video explaining protein folding. But the specific constraint was that it had to be rendered entirely in the visual style of stop-motion claymation.
And Omni generated a biologically accurate, spatially consistent representation of complex molecular biology, but mapped entirely to the physical constraints of virtual clay.
You could see fingerprints on the models, slight stutters in the frame rate, realistic lighting bouncing off the textured surfaces.
The model didn't just draw a picture. It basically simulated a physical film set in its latent space.
It did. And the tools they're building to capture human intent for these models are just wild. Look at Docs Live.
Docs Live is fascinating. The scenario is a user literally walking down a busy city street, dictating a completely chaotic, unstructured brain dump into their phone.
They're jumping between topics, interrupting themselves, referencing old conversations.
A standard transcription app just gives you a giant block of unreadable text. But Docs Live acts as a real-time structural editor.
It parses the chaotic audio, identifies the core arguments, and actually pulls in contextual data from past emails to fill in the blanks the user forgot to mention.
And it outputs a perfectly formatted, boardroom-ready strategic document.
Or flow music, where an artist can bypass the technical requirement of knowing how to use complex digital audio workstations like Ableton or Logic.
They simply vibe code the track. They describe the emotional arc, the tempo, the exact instrumentation of an R&B track, and the AI lays down the perfect technical foundation.
It removes the barrier to entry.
But I have to stop here and push back on the philosophy of all this.
Please do. This is where the real tension lies.
If we eliminate all the friction of creation, if I never have to learn how to play a piano scale, if I never have to spend hours learning how to properly light a 3D scene, if I never have to struggle through the structural outline of a complex essay, don't we lose the fundamental human struggle that makes art and even deep cognitive work actually valuable?
It's a very fair question.
Are we reducing ourselves to mere idea generators while the machine does all the actual crafting?
It is arguably the most vital critique of the generative era. But if we analyze Google's explicit design philosophy articulated in these white papers, their counterargument is that technical friction is not the same thing as artistic struggle.
Okay, what do they say their goal is then?
Their stated goal is to obliterate the barrier between human imagination and physical execution.
Obliterate the barrier, meaning the technical skill is just an arbitrary gatekeeper.
Well, think about the history of human expression. How many symphonies were never heard because the composer didn't have the patronage to hire a 50-piece orchestra?
Or how many brilliant cinematic visions died because the creator couldn't afford a lighting crew and rendering farms?
Exactly. The AI does not generate the initial spark. It doesn't have emotional intent. It doesn't have lived trauma or joy to express.
So the human being must provide the aesthetic taste and the emotional anchor.
Yes. The AI is essentially the most capable session musician or camera crew ever assembled, just waiting for the director.
So the value of the art remains deeply rooted in the human intent. The machine merely democratizes the execution.
It removes the 10,000 hours of technical repetition required to render a perfect shadow, allowing the creator to focus entirely on the emotional resonance of the composition.
Okay, I can see the argument that freeing the artist from the mechanics of the brush allows for purer expression.
Right.
But to build this frictionless world where AI can execute our imaginations and manage our carts and read our calendars, someone has to build the underlying architecture.
Absolutely. Software engineers have to actually wire this matrix together.
And this requires a massive shift in how we write code, which brings us to the developer tools they announced, Anti-Gravity 2.0 and the WebMCP protocol.
If the Agentic Era is a fundamental shift for the user, it is an absolute earthquake for the developer. We mentioned anti-gravity earlier when discussing the black hole widget in the system that built the Doom OS.
Right. Anti-Gravity 2.0 is an agent-first development platform.
It requires developers to completely unlearn imperative programming.
Explain imperative programming for context for those who might not code.
Sure. Traditional imperative coding is highly explicit. A developer writes a function that literally says, take variable A, add it to variable B, if the sum is greater than C, display this specific error message.
It's a rigid, brittle set of instructions. If the environment changes, the code breaks.
Exactly. But with Anti-Gravity 2.0, developers aren't writing explicit pathways anymore. They're writing job descriptions.
Job descriptions. I love that. They're orchestrating agents.
Yes. A developer uses anti-gravity to define an overarching goal and establish the boundary constraints. The platform then spins up a swarm of specialized subagents to figure out how to achieve that goal dynamically.
It's the difference between micromanaging every single footstep a worker takes versus giving a highly competent team a project brief and a budget and saying, hey, figure it out.
And this modular approach solves the biggest problem with early generative AI, which was catastrophic hallucination.
Because when you ask one massive monolithic model to write a complex application, it eventually loses context and writes garbage code.
But anti-gravity breaks the workflow into thousands of micro steps. You have a logic agent writing the function, a security agent instantly reviewing the code for vulnerabilities, and a testing agent compiling it in a secure sandbox.
And if it fails, the testing agent sends the error logs back to the logic agent to iterate. It's a self-healing, autonomous development loop.
It is. But for these agents to actually be useful outside of writing code, for them to act as our digital chief of staff, booking flights, or managing our universal cart, they need to be able to physically interact with the internet.
Right, they need to click buttons, fill out drop-down menus, navigate user interfaces, and historically, AI is terrible at this.
It's historically terrible because websites are built for human eyes, not machine logic.
Early automation tools relied on screen scraping, right? Literally looking at the pixels on a screen to find the word checkout and clicking those exact XY coordinates.
Which is incredibly brittle. If the website updates its CSS and moves the checkout button 2 inches to the left, the bot clicks empty space and the whole automation pipeline crashes.
This is exactly the problem solved by WebMCP, which stands for the Model Context Protocol.
Yes. Google is introducing this as a proposed open web standard, starting as an experimental trial in Chrome version 149.
This might honestly be the most consequential technical standard since HTTPS. What does WebMCP fundamentally do?
WebMCP allows web developers to explicitly expose the underlying architecture of their sites directly to browser-based AI agents in a standardized machine-readable format.
So instead of forcing the AI to look at the visual rendering of a website, The site just broadcasts a structured map of its tools.
Exactly. It exposes DOM, its JavaScript functions, its APIs, and its database query structures directly to the agent's logic layer.
Give me a real-world example. So if I tell my Gemini Spark agent to book me a window seat on the cheapest flight to New York.
The agent doesn't have to visually navigate the airline's chaotic homepage, bypass the pop-up ads, and manually type into the text boxes.
Oh, thank God.
Right. The airline's website uses WebMCP to hand the agent a direct interface. It basically says, here's the exact API endpoint to query flight times, here's the structured schema for passing payment credentials securely, and here is the Boolean toggle for selecting a window seat.
It's like giving the AI a backstage pass to the internet. Instead of making it order from the menu in the dining room like a human, WebMCP lets the AI walk directly into the kitchen and talk to the chef.
It gives the agents digital hands to manipulate the web with absolute deterministic precision. It bridges the gap between language models that can think and execution engines that can actually do.
Okay, this brings us to the most critical juncture of this entire deep dive.
Let's hear it.
We have established that these agents are incredibly powerful. They can communicate with subagents, they have digital hands via WebMCP to navigate the internet, and they are constantly processing our data in the background.
Yes.
But how do we interact with this matrix in the physical world? The goal cannot be that we spend even more of our lives staring down at a glowing rectangle in our palms.
No, the explicit design goal of the Agentic Era is ambient computing. The technology must recede into the background, it must become invisible.
And that requires a radical shift in hardware interfaces, specifically wearables.
The I/O hardware announcements focused heavily on the new Wear OS 7 ecosystem and the launch of Android XR audio glasses.
And the strategy here is fascinating because it's not a closed garden. Google isn't trying to build the physical frames themselves and force everyone to wear identical tech goggles.
They understand that glasses are fundamentally fashion and personal identity. It's not just consumer electronics.
So they provided the internal reference architecture, partnering with Samsung for the microdisplays and Qualcomm for the specialized low-power silicon, but they licensed the external aesthetic design to established fashion houses like Gentle Monster and Warby Parker.
The objective is that they must look completely indistinguishable from standard prescription eyewear or sunglasses. Because if you look like a cyborg, the social friction of wearing them ruins the ambient experience.
The hardware must be socially invisible to be widely adopted.
Exactly.
The keynote featured a highly specific, very mundane example of how this hardware ecosystem orchestrates a task, and it perfectly illustrates this concept of invisible tech.
The DoorDash example.
Yes. Imagine you are walking down a busy city street. You are wearing your Android XR glasses and your Wear OS 7 smartwatch. Your phone is buried deep in your coat pocket. You do not touch it.
You simply look at the cafe on the corner and say out loud, "Order my usual nitro cold brew from there."
What happens in the next 3 seconds is a masterclass in distributed agentic orchestration, largely powered by something they are calling the handoff API. Let's pull apart the handoff API.
Sure, because the glasses themselves are relatively dumb devices.
Right.
They don't have the thermal capacity or the battery life to run a massive LLM locally.
And you definitely don't want them storing your primary banking credentials on your face.
Right. The glasses act as a highly advanced low-latency sensor array. They possess localized spatial awareness. They use their outward-facing cameras and directional microphones to establish your context.
So they see that you are looking at the specific Starbucks on 4th Street, and they capture the audio intent of your command.
But they don't actually execute the order.
Right. Using the handoff API, the glasses instantly package that contextual payload, the geolocation, the visual target, the transcribed command, and securely transmit it to the Gemini agent running in the background on the primary silicon of your Pixel phone in your pocket.
So the phone acts as the localized server rack.
Precisely. The phone wakes up its background agent. The agent uses the new App Functions API to silently reach into the DoorDash or Starbucks app installed on your device.
It bypasses the graphical interface, navigates directly to the back-end menu, selects your saved usual nitro cold brew, and queues up your default payment method.
But obviously, a system that can spend your money autonomously without explicit confirmation is a disaster waiting to happen. The agent needs human authorization before it finalizes the charge.
But pulling out your phone to confirm defeats the entire purpose of the ambient experience.
Exactly. So the agent utilizes the Wear OS 7 integration. It sends a localized haptic vibration to your smartwatch.
You feel a tap on your wrist, you lift your arm, and the watch face displays a simplified execution prompt. Starbucks on 4th St. Nitro Cold Brew, $5.50. Tap to confirm.
You tap the glass once, maybe adjust the tip slider, and drop your arm. The coffee is ordered.
The glasses captured the intent, the phone performed the heavy computational lifting and navigation, and the watch provided the secure biometric confirmation.
The entire transaction occurs without a single app being visually opened by the user. The technology entirely disappears into the flow of your physical movement.
It is brilliant UX design.
It is. But if I can push back hard here on behalf of everyone listening, this level of integration is terrifying.
Oh, absolutely. It's a valid fear.
If my digital agents are constantly negotiating on my behalf, utilizing app functions to read my banking apps, scanning my emails for flight data, and communicating silently across a network of wearables, how do we trust this?
Trust is the whole game.
Furthermore, if the web is flooded with autonomous agents and Omni-generated video that is indistinguishable from reality, how do we trust anything we see? This feels like an absolute security nightmare.
It is the existential bottleneck of the agentic era. Google's engineers know that if consumer trust collapses, the entire agentic ecosystem collapses with it.
Because you will not give an AI your banking API if you think it can be intercepted.
Exactly. Therefore, the security and privacy infrastructure detailed in these white papers is just as massive as the AI models themselves.
Let's lay out the defense matrix. Let's start with the crisis of digital authenticity. How do I know what is real when an AI can generate a flawless video of anything?
To combat the weaponization of generated media, they are aggressively expanding the SynthNI and C2PA cryptographic standards.
What does Synth actually do?
Synth embeds an imperceptible mathematical watermark directly into the pixel arrangement or the audio frequency waves of AI-generated content, and it survives compression, cropping, and color correction.
And the crucial update here is that it's no longer just an opt-in tool for creators. They are baking synthed detection natively into the architecture of the Chrome browser and the intelligent search box.
And the sources noted unprecedented industry cooperation here. Google, OpenAI, Anthropic, and 11 Labs have all agreed to integrate these standards.
So what does that mean for the user?
This means that as a user navigating the web, you can right-click any image or video in your browser, and the OS will instantly verify the cryptographic provenance.
It will tell you explicitly. Captured by a physical camera lens, or generated entirely by Gemini, or captured by a camera, but edited with generative fill.
It provides an immutable layer of truth to digital media.
Okay, that solves the media problem. But what about network security? If my agent is constantly sending my personal data across the web to book flights or order coffee, how do we stop malicious actors or even my internet service provider from intercepting that intent?
This is where a massive upgrade to internet infrastructure called ECH, or Encrypted Client Hello, comes into play.
To understand why ECH is revolutionary, we have to understand a fundamental vulnerability in how the secure internet currently operates, the TLS handshake vulnerability.
Exactly. When you navigate to a secure website, one with HTTPS and the little padlock icon,
Right.
the actual traffic, the data you send and receive is encrypted.
Right.
However, the very first millisecond of that connection, the initial handshake where your computer asks a server to establish the secure tunnel, relies on something called the server name indication, or SNI.
And historically, the SNI is broadcast in plain, unencrypted text.
Yes. So if we use an analogy, the contents of your digital letter are securely locked inside a titanium envelope, but the exact physical address of the recipient is written in Sharpie on the outside of the envelope.
Wow. So anyone monitoring the network traffic, your ISP, a rogue node on public Wi-Fi, a state-level firewall, can see exactly which domain you are visiting, even if they can't see what you are doing there.
They know you are visiting a specific oncology forum, or a specific banking portal, or a specific political organization site.
Enter ECH.
Right. ECH encrypts that initial handshake. It scrambles the address on the outside of the envelope. Network intermediaries can no longer read the domain name.
It provides absolute cryptographic privacy from the very first packet of data sent, ensuring that your agent's background activities cannot be profiled by network snooping.
It is a massive architectural upgrade for global privacy.
It is. And looking at the local device level, I saw a feature in the Android 17 security documentation that addresses a massive pet peeve of mine, the systemic over-permissioning of apps. Specifically, the new Android contacts picker.
This represents a total inversion of the app security paradigm. Historically, mobile operating systems operated on a trust but verify model.
Right. If a random mobile game wanted to help you invite a friend to play, it would throw a pop-up asking for permission to read your contacts.
And if you hit yes,
That game suddenly had programmatic access to your entire digital Rolodex, the phone numbers, emails, and physical addresses of your coworkers, your family, your doctors.
It's an insane violation of the principle of least privilege.
The new Android Contacts Picker architecture completely isolates the app from the database. The app can no longer request raw access to the contact list.
So how does it get a contact if it needs one?
When the app needs a contact, it pings the OS. The operating system itself throws up a secure, sandboxed interface overlaid on top of the app. You search your contacts within this secure OS layer, and you manually select the specific 2 people you want to invite.
And the OS then passes only those 2 specific vCards back to the app. The app is completely blind to the existence of anyone else in your address book.
It is privacy by architectural constraint, rather than by user policy.
Brilliant. Now, we've discussed the digital infrastructure, the software security, the network encryption, but there is one final pillar required to support the agentic era without causing a global crisis, and that is physical sustainability.
Because the physical cost of computing 3.2 quadrillion tokens, running millions of background VMs, and powering all these new wearable devices is massive.
The e-waste and the energy grid draw could be catastrophic if not actively mitigated.
Google understands that an artificial intelligence revolution that inadvertently destroys the physical biosphere to power its server farms is a failed revolution.
The hardware must be engineered with a radically different life cycle philosophy, and the sources explicitly highlight the engineering of the new Pixel 10a smartphone as the blueprint for this sustainable future.
The sustainability report on the 10A is a dramatic departure from the smartphone industry's historical reliance on planned obsolescence.
They are actively engineering the device to stay out of the landfill for as long as physically possible. The Pixel 10a guarantees 7 full years of operating system and security architecture updates.
Which means the software won't artificially brick the hardware.
And the hardware itself is ruggedized IP68 water and dust resistance, but more importantly, it is built for extreme repairability.
The internal chassis uses high-contrast, color-coded screws and modular ribbon cables, explicitly designed so a user with zero technical background can order a part and replace a degraded battery or a cracked screen on their kitchen table in 10 minutes.
And at the absolute end of its 7 to 10-year life cycle, the device materials are optimized for the circular economy. The report details a verified 68.1% recyclability rate.
They've replaced rare earth mining dependencies with 100% recycled tungsten in the haptic motors, 100% recycled aluminum in the housing, and completely eliminated single-use plastics from the logistical packaging chain.
They are trying to build the physical matrix of the agentic era without leaving a toxic physical footprint.
It's an ambitious goal, but a necessary one.
Okay. Let's take a collective breath here. We have journeyed through an incredibly dense, profoundly consequential stack of information today. We have to synthesize what this actually means for the listener.
The through line connecting the TPU architectures, the WebMCP protocols, the XR glasses, and the Spark agents is a fundamental evolution in human leverage.
We are witnessing the end of the manual digital interface. For 30 years, our relationship with computers has been defined by clicking, scrolling, typing exact syntax, and painstakingly dragging data between incompatible silos ourselves.
We are moving into a world defined by declaring intentions.
You state your desired outcome, and you allow a secure, highly capable, autonomous ecosystem to orchestrate the logistical execution of that outcome across the digital and physical world.
The cognitive friction of daily logistics is being systematically eradicated.
But as we were reviewing the final pages of the Keynote transcripts, you highlighted a contrast that really stopped me in my tracks.
Yes, the dichotomy between the micro and the macro applications of this exact same intelligence.
Explain that contrast, because I think it is the perfect final thought for us to leave you with today.
Well, we have spent the last hour meticulously detailing how Gemini Spark is going to organize your kids' end-of-year checklist, how your XR glasses will autonomously order your nitro cold brew, and how the universal cart will prevent you from buying an incompatible motherboard.
These are brilliant, deeply necessary micro-optimizations of human daily life. They remove the paper cuts of existence.
But in the very same presentation, utilizing the exact same TPU-8T training architecture and the exact same core models, Google detailed systems like Alpha Earth. Alpha Earth is running massive, real-time digital twin simulations of the entire planet's biosphere to accurately model and deploy localized mitigation strategies for global climate change.
And they also detailed Gemini for Science, which is utilizing agentic subroutines to simulate billions of complex molecular and protein interactions in latent space, actively discovering viable cures for rare diseases without requiring years of physical wet lab trials.
The machine is simultaneously managing the hyperbanal logistics of your morning coffee and shouldering the burden of macro-scientific discovery required for the survival of the human species.
Which leads directly to the ultimate provocative question for you, the listener. If artificial intelligence systematically absorbs the cognitive friction of our daily minutiae, the scheduling, the drafting of emails, the shopping logistics, and it begins to master the heavy lifting of global scientific problem solving, what is left for the human mind?
It is the defining philosophical challenge of the Agentic Era. We are removing the struggle of execution.
When managing the logistical mechanics of your existence is no longer your primary occupation, what will you choose to imagine? What will you choose to create, to explore, to feel, or to connect with, using all of that profoundly freed up mental energy?
When the machine can build the operating system, compile the code, and run the game while you step away to get your coffee, what are you going to do with the rest of your day?
It is an entirely blank canvas, and the choices we make to fill that cognitive void will define the next century of human culture.
It is a staggering, slightly daunting, but ultimately thrilling prospect.
We encourage you to actively question your relationship with your digital tools as they rapidly evolve from reactive tools into proactive partners. Thank you for spending your time with us on this deep dive. Stay curious, stay thoughtful, and we will catch you next time.